Okay, hello everyone. In new video, then we have reached part 3 of chapter 11, which is the chapter of mechanical waves for grade 8 students. Then we have reached number 12, exercise 12, page 193. The title of this exercise is the speed of a wave. A child uses a vibrator as that hits the surface of the water in a pond at a rate of 50 vibrations in 5 seconds. So here we don't have the frequency, we don't have the period, we have a relation between them which is given by 50 vibrations. Corresponding for 5 seconds. Now the thing here is that the time is given by seconds, so no need to convert. Then the frequency can be calculated by placing f here, and this is 1 second. The period can be calculated by placing one vibration corresponding for the time t. So the child is supposed to be standing here. Now in 12.1 they are telling us determine the frequency and the period of the vibrator. So let's start by the frequency. Then 50 vibrations corresponding to 5 seconds, as we have mentioned, so we can place f here corresponding for 1 second. Now we can cross multiply, then f, which is equal to 1 multiplied by 50 divided by 5, this is equal to 10, because everything is expressed in the SI, so the value of f will be in the SI, which is hertz. So here we have that the frequency is given by 10 hertz. Now the period can be calculated via two different ways. The first one is given by that the period is given by 1 over f, and we know the value of f. The other way around is to place one vibration here and here capital T. So I will refer to the rule of 3. So let me say the period. 50 vibrations corresponding to 5 seconds. Now what about the period t, which corresponds to 1 vibration? We know that the period would be given by 1 multiplied by 5 divided by 50. And this is equal to 0.1, since everything is expressed in the SI, so the SI unit of the period would be seconds. Now what happens over the surface of the water? Now because this child is causing vibration at the point as causing vibrations, so we will start to observe some vibrations on the surface of the water. So let me say that we will observe, and in reality we will observe circular waves that are like this, but it's not much important for us. So what we will observe is waves on the surface of water. Now in 12.3 describe the motion of the fishing rod's ball. So this is the fishing rod and this is the ball. So as waves start to appear on the surface of the water like this, so we expect that this rod will start to oscillate or to vibrate up and down. Okay, so the rod's ball start to vibrate up and down. Now as for this question, we can eliminate it, but let me answer it. They are asking us, is there a transport of matter justified? Actually this the rod's ball will not move left or right, so it will remain in its place, but the thing is that it will vibrate only up and down. So this is it. This is the answer for this question. There is no transportation of matter, there is transportation of energy. and actually the rod's ball will not move left or right. It will not transport. It will just vibrate up and down. So let's eliminate this question. Now in 12.4, they are telling us the float is located at a distance of 24 meters. So d is equal to 24 meters. Calculate the velocity v of the wave, knowing that the disturbance emerging from us, so the disturbance is the wave, reaches the float after 4 seconds. So here, because we know the distance t and we know the duration delta t, so recall that this time, because we only have one time, this is not an instant time, this is a duration. Separating both events, the emergence of the disturbance of the wave from this point S to the rod's ball. And we know that whenever we have the distance and the duration, the speed can be calculated. V is equal to d divided by delta t, which is given by 24 divided by 4. This is equal to 6. Then this waves, for each second, it covers 6 meters. So 6 meters per second, because everything in the SI. So this is the speed of the wave. And as we have stressed previously, no need to write here m. Okay. Now moving to the final exercise of this chapter, seismic waves. Page 194. They are telling us seismic waves are mechanical infrasonic waves. So mechanical and infrasonic, both terms refer to properties of the waves, but for now we are not interested in these properties, produced by an earthquake in the bedrock. The propagation speed of these waves is given by 9,000 kilometers per hour. So let me start by writing here the seismic waves. Have an average speed of v is equal to 9,000 kilometers per hour. Knowing that 9,000 kilometers per hour is not a unit of speed, in order to convert from kilometers per hour to meters per second, we need to divide by 3.6. Then 9,000 divided by 3.6. This speed is also almost given by 2,500. Meters per second. So this speed is the speed corresponding for the seismic waves. Now we continue. An earthquake took place on December 26, 2004 in the Indian Ocean at a distance of d is equal to 600 kilometers. So the distance is given by 600 kilometers. Knowing that kilometers is not a unit of distance, in order to convert from kilometers to meters, we multiply by 1000. Then 600 multiplied by 1000, this is equal to 600,000 meters. From Bali, one of the closest cities to the epicenter of the earthquake, tsunami waves directed towards the city had a propagation speed of 800 kilometers per hour. Now what about the tsunami waves? The speed of the tsunami wave is given by v is equal to 800 kilometers per hour, knowing also that this speed is not a unit of speed. In order to convert from kilometers per hour to meter per second, we need to divide by 3.6, and this is equal to 222.22 meters per second. So what's happening here? We have the city, so the city is located here, and at a distance separating the city from the epicenter of the earthquake is given by d is equal to 600,000 meters. At a certain instant of time, the earthquake happens. So this is the epicenter of the earthquake. And when the earthquake happens, two waves travel toward the city. The first wave is given by the seismic waves, and the other wave is the tsunami waves. This wave will be responsible for the vibration that the people can feel living in the city, whereas the tsunami waves are the water waves. Okay, both of these waves are traveling at different speeds. The first one is given by 2500, the second one is given by 222.22. So actually the city will feel, the people living here will feel the seismic waves, then second on they will encounter the tsunami waves. So now let's proceed. In 14.1 they are telling us, calculate the time interval delta t1 that the tsunami waves needed to reach the coast of Bali. So we know the speed of the tsunami waves and we know the distance separating the epicenter of the earthquake and the city. Then the speed can be calculated by v is equal to d divided by delta t. Recall that in this chapter we are not placing m for v. Now constructing the triangle of this formula here, because we have divide and v will be at the bottom, d at the top, delta t here. Putting our hand over delta t, which is denoted by delta t1. So this is equal to d divided by v. So the distance is given by 600,000. Over the speed here we are calculating delta t of the tsunami. So the speed of the tsunami is given by 222.22. Plugging this on the calculator, then the answer would be given by almost 2700 seconds, because everything is expressed in the SI. So what does this time represent? This time represents the time or the duration required for the tsunami waves to reach from the epicenter of the earthquake happening at the center of the water to the coast of the city. Now in 14.2 they are asking us to calculate the time interval delta t2 necessary for the seismic waves to reach a seismograph located on the coast of the city. So in other words, the time required for the seismic waves to reach the coast of the city. So we will repeat the same exact steps, and we'll say that v is equal to d divided by delta t, constructing the triangle, putting our hand over delta t, then delta t2 would be given by d divided by v, the same distance separating both events, which is given by 600,000. Now as for the speed, here we'll use the speed of the seismic waves, which is given by 2500. Now plugging this on the calculator, then delta t2 will be given by 240. Since everything is expressed in the SI, then delta t2 will be in the SI, which is seconds. So here we have two durations, delta t1 and delta t2, corresponding for both waves, the tsunami and the seismic. And as you can notice that this is the seismic from the given, and this is tsunami. Then people at this city, we will feel the seismic waves before the tsunami. Now in 14.3 they are telling us to compare delta t1 to delta t2, and by compare we need to specify if one is greater, equal or less than, then delta t1, which is equal to 2700 seconds, and delta t2, which is given by 240 seconds. So in this case delta t1 is greater than delta t2. So here let me clarify. Delta t1 corresponding for the tsunami waves, it takes more time for the tsunami waves to reach from the epicenter to the city. We can say also the following, that the seismic waves will reach the city before the tsunami waves. Okay. Now in the same part they are telling us deduce the importance of the seismograph, and by deduce it means that we need to refer to the previous part. In the previous part we compared the durations delta 1, delta t1 and delta t2. So what is a seismograph? A seismograph is a graph that plots the amplitude of an earthquake. So seismograph is an instrument that detects an earthquake Then here we can say that the seismograph detects the seismic wave which gives an alert that other dangerous waves, and here I'm talking about the tsunami waves, may occur. Okay, so this is the importance of the seismograph. And why so? Now if you consider the difference between both intervals, then 2700 minus 240, this is equal to 2460 seconds. If you want to convert them to the minutes, then it's almost given by 41 minutes. So the thing is that people here will first feel the seismic waves. After 41 minutes, they will feel the tsunami waves. Okay, now in this time interval, which is given by 41 minutes, I think this is enough for people to take some precautions before tsunami waves to happen, although they are very dangerous. So this is it for me in this video, guys.